So there's another question they can ask you. So on each of these, we're just looking for certain areas. So they're saying here that it lies inside the first, this curve, and outside the second. So Desmos is very good at showing us this. So I've already got them plugged in. There's my top and there's my bottom because I know it's inside this but outside that. So that means this one should be inside this one. And so I've got it at 0, and let's see what happens. So as I rotate, you can see they make this shape. So I don't have to keep going. You can see right at 2 pi, it's now just recopying the blue one, but we just need to know what it is here. So you can see that this right here is our 4 sine of pi, and I actually have to keep going a little bit more to fill it in. Right there, if we want to. That's close enough. So what we're looking for is whatever's inside the blue, but outside the red. So this region right here. So a little like half moon. We're looking for this region. So you can see that we're going to do the blue, take away the red, but we need to know where those points of intersection are. We need to know right here where to start and right here where to finish. So if we know our starting point, we know our finishing point, then we can figure out what we're looking for. So like this, I need to move this one up a bit, too far. See, I need the exact value, but it's very finicky here because of where we're at here. Let me change this to 2 pi so it won't go as fast. So right about there, and this one needs to go back a bit. See, I'm moving that little blue dot right about there. So if we can find out those 2 points, then we can find out where to start it and where to stop it, and it would be the area of the blue take away the red. And you're thinking, what about these? Well, that doesn't matter because remember, it's the little sectors that we're creating. So it's that sector right there. It's the blue take away the red. This sector is the blue take away the red. The blue take away the red. All these little sectors are what we're looking for. So we need a starting and stopping, and that's the point of intersection between the red and the blue. So we set them equal. So 2 equals 4 sine theta. Dividing, we get 1/2 equals sine theta. So now we just need to know, when does sine equal a half? So that would be theta equals pi over 6 and theta equals 5 pi over 6. And we can check this very quickly with Desmos and with our graphing calculator. So if we go back to Desmos, I can then just plug in my starting value of pi divided by 6 and my ending value of 5 pi divided by 6. And you can see there it is. There's our perfect graph. And I can even do that here. I can go pi divided by 6 for my parameter to 5 pi divided by 6. And you'll see when I hit play, it traces it perfectly from where we need to start and stop. So from here to here, it'll add up all those sectors. So we're going to go from the integral of pi over pi 6 to 5 pi over 6 of top minus bottom. And you could do these separate. You could say, I'm going to take the integral of this and then subtract the integral of that one. And let's just do it that way. That way we have any integrals later, we know that we can do it. So from pi over 6 to 5 pi over 6, and then it's 1/2. And then we're going to plug in the top first. And then we're going to do it again from pi over 6 to 5 pi over 6. And like I said, you can make this into one integral if you want. But finding those points of intersection gives us our start and stopping values. So start and stop. Okay, so we have 1/2, and then it's 2 squared. That's a nice one, isn't it? Now, if we look in our graphing calculator the same way, I've already got 4 sine theta and 2. If you go to your window, you can plug those in as well. So we're going to go from pi divided by 6 to 5 pi divided by 6. And then I'm going to hit graph. And you'll see it graphs just the regions that we want. See, it's a nice, perfect little moon there, right? Perfect intersection point to intersection point. So we find the area at the top minus the area at the bottom, and it'll give it, you can see those little lines getting pushed in there. So remember, it's not the area under the curve, which goes to the x-axis. These are about radiuses and angles. So it's from here to here, line to line. Like that. So it's that area, take away that area. Now, since we are doing a video, this would work perfectly fine. But just to show you a trick, think about it this way. From 5 pi over 6 to pi over 6, the middle of this is going to be pi over 2. So you could see that, honestly, I could just do half of it and double it. And that'll get rid of the half. So if I change this to pi over 2, you can see it gives me half, and I can double it. But the reason we do that is because then we can get rid of that half. So now if I do this instead, I go from pi over 6 to pi over 2. I can now throw away that half because I'm doubling it. So why don't we write it in there too? 1/2 for sine theta squared d theta. And then that would happen as well over here. Oops, pi over 2. But it's just a way to get rid of that half. So if you can see how if you can double it, it'll work nicely. And now you don't have to worry about the half anymore. It just becomes 4 sine theta squared d theta minus 2 squared d theta. All right, so this would now give me 16 sine squared theta. And again, I'm going to have to convert it. So 1/2 would be 8. 1 minus cosine 2 theta. This just becomes 4. And so we end up with pi over 6 to pi over 2, 8 minus 8 cosine 2 theta. And what I'm going to do now is, if you notice, they both have the same interval as an integral. So we can bring them together now as 1, like that. And so now we have 4 minus 8 cosine 2 theta d theta. I'm going to move it down a little so I have room for my interval. And from pi over 6 to pi over 2 d theta. And then now we just finish this. So it's 4 theta minus, and then we're going to get 8 over 2 sine 2 theta, pi over 2 to pi over 6. I'm just going to erase that, make it a 4. And then we plug it in. So 4 pi over 2 minus 4 sine, and that's just going to be pi. And then minus 4 pi over 6 plus 4 sine of pi over 3. And so this becomes 2 pi minus 4 times 0, so that's just 0, minus 2 pi over 3 plus 4, and then that would be rad 3 over 2. And so this is just going to become 2 rad 3. All right, putting this all together, we end up with 4 pi over 3 plus 2 rad 3. All right, now we just need to check this in our calculator, make sure it's correct. So we're going to plug in that entire thing at the top, not the doubled one, but this one that we know, because the calculator is nice, it'll take care of everything itself. And they match. So top equals bottom. And there we go.